Here we have a limit with an absolute value. Now with most limits that we do algebraically, 99% of the time we're just going to take the value of x that's given to us and plug it straight into the limit. And when I do that, I'm going to get 0 over 0, because 1 squared is 1, 1 minus 1 is 0, 1 minus 1 is 0, absolute value of 0 is 0. So when I get 0 over 0, that means I got to do some sort of simplification step before plugging in 1 again. Let's start with the limit as x approaches 1 from the right of f of x, and how am I going to simplify this? Some of you might think, well, let's see, x squared minus 1 is a form that I recognize that I can easily factor into x minus 1 times x plus 1. So let's go ahead and do that. We're going to have limit as x approaches 1 from the right of x minus 1 times x plus 1 all over absolute value of x minus 1. Absolute value. But the problem is I still have this absolute value here, and you might think, well, why do I care? Can't I just cancel the x minus 1 and the x minus 1? Not quite. We have to be really careful about this. This is what we're going to use this blue information over here. So let's start with this. We're taking the limit as x approaches 1 from the right. So we're going to plug a number slightly larger than 1, like 1.1. When I plug in 1.1 into this absolute value, I get 1.1 minus 1, which is a positive number. And per the rules over here on the right, if the inside is positive, we just drop the bars. So we know that because we're taking x and approaching 1 from the right, a number like 1.1, and plug it in, I get 1.1 minus 1, which is a positive number. And like it says, because the inside's positive, we just drop the bars. And now I can safely cancel the x minus 1. You might have gone ahead and canceled earlier and just said that's fine, who cares, but it actually matters, and it will matter for the second limit we do in this video. So the x minus 1's cancel. Now I'm going to safely plug in 1. 1 plus 1 gives me 2. Kind of running out of room here. So when I plug in 1, I get 1 plus 1 is 2. Great. Now how about this limit? Well, this would be a little bit different because this is now the limit as x approaches 1 from the left. X minus 1 times x plus 1 is how that factors in the numerator still, but now when I pick my favorite number slightly less than 1, because we're approaching from the left, like 0.9, 0.9 minus 1 is a negative number. Let's go over to the blue rules here. If the inside is negative, we replace the absolute value bars with parentheses and put a negative out in front. So let's do exactly what that rule says. X minus 1, x plus 1. Because the inside's negative, we drop the bars and put a negative out in front. The x minus 1s will cancel like they did last time, and now I have x plus 1 over negative 1. And this time when I plug in 1, I get 1 plus 1 is 2, but this time divided by negative 1, giving me negative 2. So the right side limit was 2, the left side limit was negative 2, and therefore the two-sided limit does not exist. When the left-hand limit and the right-hand limit don't agree, we know the overall two-sided limit does not exist.